Oh, he's catching up to you. Oh, you barely missed it. Let's see if mine misses it. We got almost the same. Ah, mine found it.
Why didn't you find it and mine didn't?
All right, you got it.
Hey everyone, I'm very excited to bring you another experiment with the V3 robot. And this is line following with a twist using IR sensors that are on the bottom of the robot. So I call it with a twist because what happens is we're going to have a black piece of tape on a white surface, and we're going to have the robot go around the following the line, either on the side or in the middle. Just follow the line, the black line, and it has to avoid hitting an object, and it should continue around the object and continue following the line, make a U-turn and come back where it started. So it'll start in a place, go all the way to the end, make a U-turn automatically, come back, avoid hitting the object, come back and finish where it started. It doesn't have to stop at the end, but it has to go through the finish line here. And if you are at home and you don't have a line follower, you can easily build, put a sheet of paper and just make like a half moon shape and see if the robot can follow that line with a piece of tape. So I'll show you a few things on how to do that. But that's the idea of line following. I'll show you a couple of videos of what that looks like. So there's gonna make a U-turn. So the robot has already started. It went all the way to the end. It's another robot that got out of the way.
Oh, he's catching up to you.
So it's supposed to hit the object, go around it.
Oh, you barely missed it.
What the hell?
Let's see if mine misses it. We got almost the same. Ah, mine found it.
Why didn't you find it and mine didn't?
All right, you got it.
So it ends right there. Okay, so you get the idea of what we're gonna be doing, and let's see if we can do this. All right, so first of all, we're gonna be using some sensors. This is it's called the Funduino. It's got 3 infrared sensors on the bottom, and basically it transmits lights, and when it detects something, it registers it. The green LEDs is a status saying that it registers something underneath it, so it's just a little indicator, but we don't use it unless we're testing it. A little bit of what that looks like. Let me show you on the robot itself what that looks like. Okay. Be sure to put in these spacers here, because those spacers will allow the distance between the robot, the sensor, and the ground to be the exact distance that you need. Okay, so you're using those extra horns from the servos that came in the little bag of servos. We're using those, and I believe you put this in when we first assembled the robot. Okay, so it's got all this wiring, all these connectors over here, and there's labels. It's kind of hard to tell, but there's labels that you can see right there. All right, so you have the 5 volts, the ground, and then you have the left, center, right. Okay, so 5 volts, ground, left, center, right. So we're going to be using these wires, and what I like to do is I like to extend them. So we grab the male to female, and then we'll put in a couple of female to females. And so now we have a really long female to female cable that we can use between the sensor down there, right, between those connectors that we have. You can put in the wire and then plug it on the right spots up here in the analog input connectors. All right, so you'll need 5 of those. So you should have enough cables to create those. Let's take a quick look again here. So here's a better view of what those sensor connectors look like. All right, so you have your 5 volts, and you'll use the 5 volts from the center area here. You'll use the ground also from the center area here. And then we'll have our left, center, right sensors. We're going to be using analog inputs 2, 3, and 4. Okay, so this is our little IR sensor. It goes connected onto the Arduino sensor shield. So those sensors that we have down here are the TCRT 5000 IR sensors, and they're typical line following sensors. Let's see if we have a little bit of more of the specs here before we test them. So you can see that you have a little transmitter and a little receiver here, and it's just a little infrared sensor. Okay, and let's see, we can start connecting them, and then we'll do a very quick test where on the computer screen via the serial port, right, using the serial monitor, we'll be able to look at the sensor value, and then you'll see exactly what those sensors are reading. Okay, now for the final connection, you can use all 3, or you can even use a single sensor to follow a line. I personally like to use the single sensor. It makes it a lot easier, but some people like to use 2, some people like to use 3. It all depends on your preference. But for example, if you wanted to, because the tape, you're going to be using just a piece of tape like this. Right. So when you put the sensor down here, okay, that piece of tape is just going to go down there. You're going to be reading that piece of tape down there with this sensors, and so you can read it with one sensor, you can read it with the left and the right, and so you can go right on top of the line, or you can follow the line along here like that with the single sensor. I'll explain more in details about that later on. In the meantime, let's wire this up. I'm going to wire all these things right now, and we'll do some testing. Okay, so I've wired everything up. I have all of my sensors connected now, all of the 3 sensors and the power. And I decided to, let's see, we're using for this one, we're actually using this row that you see over here. Right, this is the analog pins. This whole row here is the analog input. I don't know if you can see the letter A. We are all connected to the analog inputs over here. The letter A is 2, 3, and 4. All right, so now let's test that sensor. We can copy from the sample from here, but this one only gives you the reading one at a time on a single line. So what we want to do is, let's see, where is the sample? This one right here. So what we want to do is we want to read all of them and display them one at a time so that we know exactly which ones, because this one, let's show you real quick what this one does. So it's done uploading. Let's open up our serial monitor, and it's reading all 3 sensors at once, and it's giving you some values, right? You put in your fingers or your hand on the bottom here, and you can see that You can also see the lights turn on as you hit each sensor here, and you see the values changing in there. Let me show you how to test each one again real quick using another method here. If you go to File and you go to Examples and you go to Analog Input, there's a nice example here, and I'm just going to delete the comments here on the top so it makes it a little bit cleaner. And there's also some kind of an LED thing in there, which I don't need. So I'm just going to delete the whole LED stuff. Okay, because all I want to know is what's in the ports A2 to ports A3 and 4. A2, 3, 4. And so we can read one pin at a time. We can just okay, so we'll need to display to the serial monitor, we'll need our serial.begin at 9600 baud, and then we're going to need some kind of a serial print here. So we're reading the sensor, delay sensor value. Now we want to do this every 1 second. And you can do a serial.print line, and we can just say A2. We can do a comma, and we can just say, let me print what the sensor pin is, or actually it will be the sensor value. Sensor value. Okay, so that should read one of them. So let's see what happens there. Let's see. Oh, misspelled. Did a letter U there. And no matching function call for print ln. All right, let's do a serial print then. And let's try that. Okay, so that one's not working, so let me look at another example real quick here. We can do, see, the basics, digital read. This one should show us a little bit more. Okay, so we can do something like this. Sensor value. Okay, let me try with that, all of that. Okay, so it looks like I didn't need to put anything else. So let's look at the serial monitor, and we can see the value for the one sensor. And we can do this. Actually, we can put a serial.print A2, and this should allow us to print a label on top of it. Okay, done uploading, and there it is, my A2. I can say A2 is equal to, and what I can do is I can declare other values here so that I can have all sensors. So I can copy this, for example, label that to A3, and I can say sensor pin 3, sensor value 3, right? And I can, I would have to redo this one. Control C, sensor value 3, analog read of sensor pin 3, and I can do this. Can do another delay. All depends how you want to display it, but we can do A3, sensor value 3, let's run this one. So now let's look at two sensor values. So there's A2 and A3. I can do this, right? Now, why is it showing the same value for both sensors? I'm only touching one sensor, so that means I am reading the same values on both pins. So I got sensor pin A2, 3, okay. I'm reading that sensor value. I'm reading this one, sensor pin 3, which is A3. Okay, okay, and then I'm going to print each one of them. Alright, so that should actually be okay. Let's see what happens here. Let's show you the camera a little bit. So that one shows that A3 is touching something, is covering it, but A2 is okay. So if I come to the A2, now A2 is covered and A3 is not covered. Okay, but actually I should be showing you this. Okay, you can see that that sensor is triggered. Right? But when I do the opposite, A2 will become a lower number and A3 a higher number. Alright, so with this I wanted to show you a few things. I wanted to show you that you can just grab a sample like I did, right? Like an analog input sample, and I could test any analog sensor that's out there. I can just plug it into the right port and I can read the values of it. Alright, so let's move on to the next examples here. This one does the line following demo, uses all three sensors. And let's see how this one works. Okay, we're gonna copy this guy. And let's open up a new session. Delete what's in there. I got my servos attached to pins 10 and 11. It looks like I'm looking for a threshold of 650, but it really all depends on what you have as far as lighting, as far as the tape. But in the meantime, let's run this up and see what happens. Alright, so like I told you, in your own comfort of your home, you can have a white area, a white sheet of paper, or you can get a white cardboard box or something like that from the hobby store, and just roll tape, electrical tape, put in a line. Right, I got that sample, and we're going to use our line following sensor, all three sensors. I want to put this here, and I'm going to turn it on, and it's supposed to follow the line. Right, so let's see what happens. Okay, and then it actually stops at the end because it's only looking at the white area. So if you look at it right now, right, it stops when it sees the black line. Eventually it'll align itself and it'll try to follow the line correctly. Alright, so we know that our sensors work, and this is also a preview of the sumo wrestling, where we're going to make a circle and your robot is going to have to stay within that circle and try to find another robot and push it out of the circle. We're going to do an exciting lab next time for the sumo wrestling. But this is pretty neat. You can see the sensors working, right? soon as it finds the sensor, it stops, it tries to align itself to follow that line. So, line following sensor. Now, your job for this particular lab is to not only make the line following sensor, but you should have an object that the robot can sense. So I would use whatever sensors you want. You can bring back your little feeler sensors if you like we did in the video, or you can use the IR sensors. It all depends on the object that you put in front of it. Okay, but you can put anything that you like that you think is going to be a good obstacle avoidance sensor. So it all depends on the sensor that you use, but you can put something like that where it detects that there's something in front of it, and then it tries to go around it, and it continues following the line. Okay, so that's the whole idea behind it, just like you saw in the next video demo that I'll show you. All right, but that's your job. Figure out how to integrate the sensors to this line following. If you don't want to use all three sensors, you don't have to. Okay, you're welcome to just use one of them, or use all three of them. Right now this one is using all three of them. Okay, good luck with that one.
Come on, baby. Uh-oh. That's fine, that's fine.
Oh, are you controlling it?
No.